Hello students, welcome back to today's class on polynomials, and that today we're going to discuss about division algorithm. Division algorithm, that means there is some pressure to divide polynomials which we are going to learn today, right? My name is Avinash and I'm a graduate from IIT Kharagpur. Let's start today's session. So what is the first thing we are going to discuss is a division of algorithms. Let us say we are dividing some numbers. How do you divide some numbers? Okay, let's say you're dividing 5 and 7. Okay, so 5 ones are 5 and you're left with 2. And you know, 7 is equal to 5 into 1, 5 into 1 plus 2, right? 5 into 1 plus 2. We do that for the normal numbers. But is it valid for the same for polynomials? Let's try to discuss that, okay? So first let's divide x plus 2. They divide this one by x plus 2. So the same like normal division, right? X plus 2, and this is a 2x square plus 3x plus 1. Okay. So here I'm not going to give you that this is step 1, this is step 2. Try to understand the method. Try to understand the method from the way we are doing. Okay. The very first thing is divide these two first terms. Divide 2x square by x, 2x square by x, so that will give you 2x. 2x square by x will give you 2x, right? So 2x will come here, 2x will come here, correct? Now multiply this complete x plus 2 with 2x. Multiply this complete x plus 2 with 2x. Tell me what you'll get. Let me erase this. Multiply x plus 2 with 2x. So x into 2x is 2x square plus 2 into 2x is a 4x. And now you need to subtract these two. You need to subtract these two. So when you subtract, I told you many cases when you're subtracting, the sign changes. If you have positive, that changes to negative. If you have negative, that changes to positive. These two are positive values. So these two will become negative. 2x square minus 2x square gets cancelled. 3 minus 4x, so 3 minus 4x becomes minus x and plus 1. Now again, divide the first two terms, just like 2x squared by x you have done. Now divide minus x with x. Minus x with x, minus x with x, so that becomes minus 1. That becomes a minus 1. So if you keep minus 1 here, multiply this x plus 2 completely with minus 1, that becomes x into minus 1 is minus x. Plus 2 into minus 1 is minus 2. So if you do this, what will get? So negative will become positive, negative will become positive. So these two gets cancelled. Plus 1 plus 2, you will get the remainder as 3. You will get the remainder as 3. Okay. So x plus 2, if you're dividing 2x square plus 3x plus 1 by x plus 2, we are getting a quotient of 2x minus 1 and the remainder as 3. Right, so let's move forward to see what else we can learn in the division of polynomials. It's a very simple, right? Okay, so once again, let's try to is this the same question? Yeah, let's try to verify this one where we have dividend is equal to divisor into quotient plus remainder. What is dividend? What is divided? What is quotient? What is remainder? If let's say the same example we had discussed 5, 7, 5 ones are 5 and 2. I wrote 7 is equal to 5 into 1 plus 2. Okay, so the number here, the number inside the actual number which we are dividing, that is called dividend. That is called dividend. And the number by which we are dividing, that is called divisor. And the value we get in the other bracket here, this portion is called quotient. And finally, whatever the number is left, that is a remainder. That is remainder. Dividend is equal to divisor into quotient plus remainder. Correct. So in the same way, let's try to verify that dividend is the main part, that is 2x square plus 3x plus 1 is equal to divisor. Divisor, here it is x plus 2 into quotient. From where we get quotient? From the previous slide. Quotient is this one, 2x minus 1. 2x minus 1, okay, 2x minus 1 plus we have a remainder. Here we have the remainder as 3. So let's try to verify whether it is correct or wrong. So multiply x into 2x is 2x square, x into minus 1 is minus x, plus 2 into 2 is plus 4x, plus 2 into minus 1 is minus 2, and plus 3. So we get 2x square plus 4x minus 3x is plus 3x, 3 minus 2, 3 minus 2 is 1. So what we got? We got the same answer, which is 2x square plus 3x plus 1. 2x square plus 3x plus 1, we got the same answer, and hence we can say that it is valid even for polynomials. Let us discuss one more question, how to divide, because the one which you learned might be very simple, but let's move forward for one more example of the same thing. Now we are having a cubic polynomial. 3x cube plus x square plus 2x plus 5 by 1 plus 3x plus x square. We need to divide these two. So write this properly in the standard way. X square plus 2x plus 1, and this one is 3x cube plus x square plus 2x plus 5. 3x cube plus x square plus 2x plus 5. So x square and 3x cube, divide these two. First of all, divide these two. 3x cube by x square will give you 3, and x square, x cube gets cancelled, will get x, 3x. So write that 3x here and multiply this complete thing with 3x. Multiply this complete thing with 3x. X square into 3x becomes 3x cube. X square into 3x becomes 3x cube plus 2x into 3x. 2x into 3x becomes 6x. 2x into 3x becomes 6x square plus 1 into 3x becomes 3x plus 1 into 3x becomes 1 into 3x becomes 3x, right? So now if you cancel these two, that means if you divide these two, subtract. If you subtract these two gets cancelled. X minus x square becomes minus 5x square plus 2x minus 3x becomes minus x, and we are left with once again with the number 5. Again, divide this first one with this first one, that is minus 5x square by x square. So you will get minus 5. That minus 5, write it here. And multiply this complete thing with that minus 5. Minus 5 into x square is minus 5x square. Minus 5x square. Minus 5 into 2x is minus 10x. Plus 1 into minus 5 becomes minus 5. So all these gets cancelled. I mean, when you subtract, these two gets cancelled. This becomes plus 10x minus x becomes 9x. And this becomes plus, so this becomes a plus 10. Okay, so this is the quotient 3x minus 5, and this is the remainder 9x plus 10. But once again, please try to check everything, whether it is correct or wrong. There may be some calculation mistakes. So you just please try to check that and write it properly, right? Now, let's discuss about division algorithm, which we have discussed previously. Whether it is correct for polynomials or not, yes, it is correct. Okay, so that is the algorithm that we are going to discuss. If p of x and g of x are two polynomials with g of x is not equal to 0, then we can find the polynomials q of x and r of x such that, okay, leave all those. You're dividing p of x by g of x. So p of x you're dividing with g of x, you're getting a quotient. We get quotient, right? That is q of x, and finally you get remainder, which is r of x. We are just writing p of x, polynomial in x, quotient in x, remainder in x, just some notations, that's it. Okay, so p of x is equal to g of x into q of x, g of x into q of x plus r of x. G of x into q of x plus r of x, correct? Either r of x is equal to 0, the remainder sometimes 0. The remainder sometimes is 0, or degree of r of x, that means degree of remainder is less than degree of g of x, Is that correct? Let's move forward, let's move back. This is a second degree, x square. This is a second degree. This is a first degree, 9x. So definitely the remainder is less in terms of degree than compared to this the polynomial which we are dividing with, divisor. Okay, so we can see here, either remainder is 0 sometimes, if it is perfectly cancelled it is 0, or degree will be less than the degree of g of x if r of x, if remainder is not 0. Okay, So this result is known as division algorithm for polynomials. Division algorithm. P of x is equal to g of x into q of x, g of x into q of x plus r of x. The same method which we learn for numbers, the same method, the same thing. But in polynomials, instead of numbers, we get different terms with the different variables. Right? So let's move forward to see more applications. Divide 3x square minus x cube plus minus 3x plus 5 by x minus 1 minus x square and verify the division algorithm. Verify the division algorithm. Is it the same thing which we have discussed previously? No. But write this one as properly, because we have a negative x square. You should not get confused with negative. Minus x square plus x minus 1. This is a 3. We have minus x cube. The first one we are having is minus x cube. Don't forget that. So minus x cube plus 3x square minus 3x plus 5. Always write in the standard formats. X cube, then x square, then x, then constant. Every term should be descending in terms of their degree. Okay. So minus x cube and minus x square, if you divide minus x cube and minus x square, minus and minus gets cancelled, x cube by x square becomes x. X cube by x square becomes x. So that becomes x here. When you multiply minus x square with x, you will get minus x cube. X with x becomes a plus 2x. Minus 1 with x becomes a minus x. One thing, x into x becomes a minus plus x square, not 2x. It is x square. It is x square, right? So now let's try to subtract these two. So this is plus, this is minus, this is plus. Minus x cube and plus x cube gets cancelled. 3x square minus x square. 3x square minus x square is 2x square. 3 minus 1 is 2x square. Minus 3x plus x is minus 2x. Minus 3x plus x is minus 2x. Once again, 3 minus 1 is 2x square. Minus 3x plus x is minus 2x. And we are left with plus 5. That 5 will come here. Now, 2x square divided by minus x square. 2x square divided by minus x square. X square gets cancelled. That we will get a minus 2. You will get a minus 2. So if you multiply, that becomes a minus 2. If you multiply with minus 2, minus 2 into minus x square becomes a plus 2x square. Correct? Plus x into minus 2 becomes a minus 2x. And minus 1 into minus 2 becomes a plus 2. So if you subtract these two, what will get? So these two terms gets cancelled. These two terms gets cancelled. 5 minus 2 will give you 3. That is the reminder. But the question is, verify the division algorithm. We need to verify whether it is correct or wrong. What is that? P of x is equal to, okay, that dividend minus x cube plus 3x square minus 3x plus 5 should be equal to divisor into quotient. So this is minus x square plus x minus 1 into x minus 2 plus the remainder plus 3. So let's multiply and let's check that. I know it's a bit difficult or a lengthy question, but it's very easy. No complicated calculations here. Minus x square into x is minus x cube. Minus x square into minus 2 is a plus 2x square. X into x is plus x square. X into minus 2 is minus 2x. Minus 1 into x is minus x. Minus 1 to minus 2 is a plus 2 plus 3. Plus 2 and plus 3, right? So what we'll get here? Minus x cube plus 2x square plus x square is a plus 3x square. Minus 2x minus 3 minus is minus 3x. Plus 2 plus 3 is a plus 5. Minus x cube plus 3x square minus 3x plus 5. Minus x cube plus 3x square minus 3x plus 5. So this is exactly same as the given function. So division algorithm is verified. Division algorithm is verified, right? Let's move for one more question. So what is the next one? Find all the zeros of 2x power 4 minus 3x cube minus 3x square plus 6x minus 2. If you know that two of its zeros are root 2 and minus root 2. See, this is x power 4 term, right? X power 4 will have 4 roots. Out of that, 4 zeros. Out of that, 2 zeros are already given. Let's go back to the basic polynomial, basic factor, basic zero. What is the definitions of all those? If A is a 0, I told you if A is a 0, x minus A is a factor. X minus A is a factor, correct? In the same way, as root 2 is 1, 0, x minus root 2 is 1 factor, and minus root 2, x plus root 2, x minus of minus root 2, x plus root 2, these two are the factors. These two are the factors, correct? So, what is the product of these two factors? X minus root 2 and x plus root 2. X minus root 2 into x plus root 2 will give you a plus b into a minus b. A plus b into a minus b. What is the formula? A square minus b square. A square minus b square. X square minus root 2 whole square. That will give you x square minus 2. X square minus 2. Root and square gets cancelled. Becomes x square minus 2. Correct? So, now for this, one of the factor is x square minus 2. So we need to find the other factors. From there we can try to find the remaining zeros. Okay. Find all the zeros. We already know 2 zeros. Let's try to find the remaining things. Okay. So now let's go for division again. X square minus 2, and this is the 2x power 4 minus 3x cube minus 3x square plus 6x minus 2. Right. 2x power 4 by x square. 2x power 4 by x square and x power 4 gets cancelled with x square term. You will be getting 2x square. So keep 2x square here. Multiply x square with 2x square, will get 2x power 4. Minus 2 with plus 2, if you multiply, minus 4x square. Minus 4x square, no x cube term here, be careful. There is no x cube terms, that becomes 0. And we're having minus 4x square. So now if you subtract, these two gets cancelled and this becomes positive. This minus 3x cube, 4 minus 3 is a plus x square and plus 6x. So now minus 3x cube by x square, divide the first two terms. Minus 3x cube by x square will give you minus 3x. Will give you minus 3x. So that becomes minus 3x cube. Okay, so that becomes minus 3x, correct? So x square into minus 3x is minus 3x cube. Minus 2 into minus 3 is minus 6x. Minus 2 into minus 3x is plus 6x, minus 6x. So if you subtract, these two gets cancelled, these two also gets cancelled. Oh my god, these two will not get cancelled. So x square will come directly as x square, and this becomes a plus 12x. We have done some small mistake. It's not plus 6x. Okay. X square into minus 3. X square and minus 3 is minus 3x cube. Minus 2 into minus 3x. Minus 2 into minus 3x becomes a plus 6x. Plus 6x. So when you're subtracting, these two also gets cancelled and you're left with only x square. Left with only x square. And this minus 2 will come here. X square minus 2 and x square minus 2. So it's exactly 1 times. So just write 1 and you can get x square into 1 is x square. Minus 2 into plus 1 is minus 2. So these two values gets cancelled and you'll get the remainder as 0. Remainder is 0, okay, but what about the other zeros? The question is asked about find the other zeros. Where are the other zeros? The other zeros will come from this factors, from the zeros of that. Okay, so what is the new function we are having? We are having 2x square minus 3x plus 1, or you can write q of x, quotient. So now I am not going to do that. You already know how to solve quadratic polynomial, how to factorize. So please try to factorize this one to get the other two roots. Okay. So let me try 2 into 1. You need to find what is the product of these 2 into 1. For that you need to write the factors. You need to write the factors as that the sum is minus 3. So we can write minus 2 and minus 1. So 2x square minus 2x minus x plus 1. So what we can take common? We can take 2x common, you will get x minus 1. Minus 1 common, again we will get x minus 1. So you will get x minus 1 into 2x minus 1 are the factors. If these are the factors, you need to bring what are the zeros. X minus 1, make that to equal to 0, you will get x is equal to 1. And 2x minus 1 is equal to 0, you'll get 2x is equal to 1 and x is equal to 1 by 2. X is equal to 1 by 2. 2x is equal to 1 and you'll get x equal to 1 by 2. So x equal to 1, x equal to 1 by 2 are the other two zeros other than root 2 and minus root 2. A very beautiful question. All they took a lot of space, lot of time to solve this one. The point is when you have two roots or two zeros, using that zeros you need to find what is the factor. Using that factor you need to divide it and you need to bring the other two factors. From those two factors you need to bring what are the zeros, right? So the final answer is x equal to 1 and x equal to 1 by 2. Clear? A very beautiful question. Once again, please try to do that on yourself, right? So let's take one more question. Find all the zeros of the same question, I guess, right? 2x cube, same question. Let's move forward. On dividing x cube minus 3x square plus x plus 2 by a polynomial, the quotient and remainder were x minus 2 and minus 2x plus 4 respectively. Find g of x. What is the meaning of that? On dividing x cube minus 3x square plus x plus 2 by a polynomial g of x, we are trying to divide with g of x. So what we are getting here, the quotient is x minus 2 and the remainder is minus 2x plus 4. So to find g of x, we have few division algorithm. What is that? Okay, the dividend x cube minus 3x square plus x plus 2 is equal to divide the g of x into quotient x minus 2 plus the remainder minus 2x plus 4. So now if you expand this one and if you try to do it properly, you will get a g of x. So try to bring this minus 2x plus 4. Tell me. X cube minus 3x square plus x plus 2 minus 2x will come here plus 2x plus 4 will come here minus 4 is equal to g of x into x minus 2. So what will get? X cube minus 3x square plus x plus 2x is plus 3x plus 2 minus 4 is minus 2 by x minus 2 will give you g of x plus 3x. Okay, by x minus 2 will give you g of x. So I am not going to do that. You try to substitute, you try to find the division of this one and you can get the answer. That will be the value of g of x, right? So let's move ahead for one more. Okay, divide the polynomial p of x by the polynomial g of x and find the quotient and remainder in each of the following cases. The same thing we have discussed, right? So x square minus 2 will be here. X cube minus 3x square plus 5x minus 3. So you need to divide with the division algorithm, whatever we have done. And you need to find the quotient and remainder. Whatever you get here, that becomes the quotient. Whatever you get in the final, that becomes remainder. Okay. The same way we have a couple of more questions that you can try. This is the second question, which you can try. You can take it as a take-home assignment. So p of x is x power 4 minus 3x square plus 4x plus 5 and given g of x equal to x square plus 1 minus x. So please try to do that. So I hope all these questions are clear to you, right? We have discussed a lot of things in polynomials, not just one, two. We have discussed what are polynomials and also we have discussed division of algorithm, right? So with all this information, we'll again have a new quiz in the coming week, right? Thank you so much, friends. Stay tuned to get the next lecture. Thank you.
Hello everyone, so now we'll be discussing about refraction, but refraction at curved surfaces. Okay, so my name is Shashan Reddy, I'm a graduate from IIT Dhanbad. Let's go into the class. So until now you would have learned about refraction, yes, but refraction at plane surfaces. So try to remember all the cases that you have learned regarding refraction. You would have learned about refraction in a rectangular glass slab. You would have learned about the real and apparent depth. You would have learned about refraction of light by a prism. Now look at all of them. If you look at the surface, we show them as a line. But the surface will actually be a plane. So these were the cases of refraction at plane surfaces. The boundaries were plane. But now we'll go into the case where the boundaries are spherical, are curved. Okay, they will be curved. And you know, when we take a curve, the basic case of a curve is a circle, or when we take curved surfaces, the basic case is a spherical surface. And so we'll be discussing mostly about spherical surfaces. So if I take a spherical surface, a part of a spherical surface, and if I complete it, I'll get a sphere. As the sphere would be something like this. Yes or no? So this from here to here is the surface that we are talking about. And every curved surface and every spherical surface will have two surfaces. You can clearly see surface 1 and surface 2. One of them is called concave and the other is called convex. The inside one is called concave and the outside one is called convex. Yes or no? The surface that is inside the sphere, that would be inside the sphere, is called concave, and that would be outside the sphere is called convex. So this here is convex and this here is concave. Understanding the naming is very important. Good? Okay, so now we'll be going into what happens when light will be incident in any way on a curved surface. What happens to that? It can be incident on surface 1 or it can be incident on surface 2. Then what happens to those rays? How will they be refracted? And if there is an object placed, where will we get the image? We'll be learning about all of them. So let's go into them one by one, shall we? Okay. So first of all, look at this. So mostly we'll be discussing about these two surfaces, these two types. So what are they? Here if I look at the first case, the top case, generally I say this is air and let's say this is any medium. The medium you can consider it as glass, you can consider it as water. So generally we just go with medium, but the best example is glass. Similarly here also this is air and this is glass. And where will the light be incident on? Light will be incident on this surface. As you can see, it is curved, okay? And the curve will mostly be a sphere. The curve will mostly be a sphere. That's what we are discussing about. Sir, do we have other type of curved surfaces? Yes, we have. But we will restrict ourselves to the discussion of curved surface. Okay. So here, two spherical surface. Okay. Here you have a part of a spherical surface, and every spherical surface, if I complete that, I will get a sphere. It will have a center, and that center is the center of curvature of this surface. Yes or no? So if you have a curved surface, the surface, let's say spherical curve, you can complete that, you can get a sphere, and that sphere will have a center. So this surface has a center, that's here. And what about this surface? Where will it have its center? Towards right or towards left? Look at the curve. Where is center? If you complete it, the sphere will be something like this. So the center will be towards left, so center is here. Got it? So if you have a curved surface, identifying the center is important. And where will the light be incident? The light will be incident on the curved surface. We'll be going into different cases, don't worry. We will be going into different cases and we will understand all of them. So our target is to learn refraction at a curved surface. And here also for these curved surfaces also, we can define concave and convex. The outer surface is convex. The inner surface is concave. Inner and outer are with respect to the sphere. This is the sphere for this. But if I come into this, this would be concave and this will be convex. Got it? We'll go into each of them. You need not worry how refraction occurs and all. We'll go into all of them. But one point is, the laws of refraction are valid even for curved surfaces. So even here the laws of refraction are valid. The surface can be of any shape, it doesn't matter. The laws of refraction will be valid. Both the laws. The incident ray, the refracted ray and the normal lie on the same plane, valid. Sin I by sin R is equal to refractive index of second medium with respect to first medium. That is Snell's law, valid. And based on them or using them itself, we get the refracted ray. Is that clear? Okay. Let's go into one by one. Let's go into each case one by one. Okay. So first of all, let's look at the normal at curved surface. So again, we'll say normal at what? Spherical surface. We'll mostly take spherical surface. So at normal is what? Normal will be perpendicular to what? The surface. So at any point, if I take this point here, point P, the surface would be the tangent and perpendicular to tangent would be the normal. Is that clear? So keeping that in mind, remember this, at any point on the surface, if I want to draw a normal, it will pass through its center. See at this point A, if I am drawing the normal, it is passing through its center, the center of curvature. Here also it passes through center. Here also it passes through center. So at A, at B, at M, at all these points, the normals pass through the center. The normals pass through the center. And what is this distance from C to B? C to B is the radius. C to A is the radius. C to M is also the radius. Because if I have a circle from the center to any point on the circle, center to any point on the circle is nothing but radius. The same is true for a sphere also. From center to any point on the sphere, it is radius. So even for this curve, even for this spherical curve, from center to any point, I can draw till here, till here, till here, till here. All of them are radii. All of them are what? Radii. So you have to be careful. Understood? So these are the normals. The same will work or for this also. At any point, if you draw the normal, the normals will pass through the center. So what is the point? Normal passes through. Normal at any point on a spherical curve. On a spherical curve passes through the center. Passes through its center. Is that clear? Good. Chalo. We understood normal. Because see, why is normal important? For the laws of refraction to be valid, or for us to be able to use the laws of refraction or the Snell's law, we need normal, because you get angle of incidence using the normal. You get angle of refraction using the normal. So that is the reason why it is important. So we figured out how to get the normal. Done? Now let's go into the other case. The simplest case next would be normal incidence. That is, if I have an incident ray, if this is the incident ray, and if I draw the normal at that point, it passes through center, and you can clearly see the incident ray is along the normal. The incident ray is along the normal. It is parallel to normal. So when the incident ray coincides with the normal, it is the case of normal incidence. Which incidence? Normal incidence. And what happens in a normal incidence? The light does not deviate. The light does not bend. The light directly passes through. Light will pass through along the normal, and you can see the refracted ray directly passes through without any deviation. Without any deviation. And in fact, in this case, angle of incidence is 0 degrees and angle of refraction is also 0 degrees. Now it is valid at any point. It is valid at any point wherever you have normal incidence. Is that clear? Good? Okay. Chalo. Now I can take another case. Same case of normal incidence. I'll take normal incidence again. But the ray is incident at any other point. Let's say at this point. This is the incident ray. If I draw the normal at this point, the normal passes through center, and as you can see, the incident ray coincides with the normal. The incident ray coincides with the normal. It is the case of normal incidence. The ray directly passes through without any deviation. Good? Simple. Okay. Then, I'll go into another case. Let's say this is the incident ray. Now look at this point A. Is the ray along the normal? No. So it is not the case of normal incidence. Then what happens to this ray? To figure out that, you have to first draw the normal. So this is the normal. Okay, we have drawn the normal. And then you have to identify which is rarer medium, which is denser medium. Here I have told you we have been taking this case, outside is air, inside is glass. Which means outside is a rarer medium, inside is a denser medium. So here air is rarer, glass is denser. So the ray is going from rarer to denser medium. That is the case that we are discussing. Rarer to denser medium. And when a ray travels from rarer to denser medium, what happens? It bends. It bends towards the normal. So the refracted ray will be something like this. As you can clearly see, this should have been the direction of incident ray. It is bending towards which direction? It is bending towards normal. This is the normal. So bending towards normal because the ray is passing from rarer to denser medium. Is that clear? Simple? Good. Okay. Wonderful. Chalo. Rarer to denser medium. We'll take other examples also. I'll take the other surface. Right. So here this is the surface and you can clearly see that this is the center. Okay. Now here this surface, this first surface, is it concave or convex? Is that concave or convex? This would be, the first surface would be concave because if you complete the sphere will come to be something like this. This is inside is concave, outside is convex. Okay, so keeping that in mind, I'll just write it down here. It is concave here, it is convex here. And if I take a ray, let's take a ray. I first drawn the normal and then I have taken the ray just to show it. So the incident ray is incident along the normal. It is passing through the center. That means it is coincident with the normal, right? It is passing through center. It is coincident with the normal. That means it is the case of normal incidence. So when it is the case of normal incidence, we need not worry about anything else. The ray directly passes through without any deviation whatsoever. Okay, and because the incident ray is incident on a concave surface, we say refraction of light at concave surfaces. Because the incident ray is incident on the concave surface, it is refraction of light at concave surfaces. Clear? Good. We'll take other example also. Again, normal incidence. See here, there is a center of, this is a normal. And if a ray is incident along the normal, it is passing through the center. If it is incident along the normal, then what happens to it? It directly passes through. You can see refracted ray is also along the normal. So this also is the case of normal incidence. So here the ray passes through center. Ray passes through center of curvature, so it directly passes, no deviation. Yes, but I think we had another case. Here the incident ray, if you look at the incident ray, it appears to pass through center. So if the ray actually passes through center or if it appears to pass through center, doesn't matter. What happens? It passes undeviated. It passes undeviated. Okay, some statements, that's it. Okay, we discussed that. This is also done. Clear normal incidence for both the cases we have discussed. Then we'll go into this case. We'll go into the other cases. Other cases will mean cases other than normal incidence. So if I have a ray, this is the incident ray. at this point, just look at this. Is the ray passing through center of curvature? No. Is it along the normal? If it is not passing through center of curvature, it is not along the normal. Still, this is the normal, this is the incident ray, it is not passing along the normal. That means this is not the case of normal incidence. Then what will we do? We have to first figure out whether it is going from denser to rarer or rarer to denser. How I said it is going from air to glass. We have taken the example of air to glass. Air is rarer and glass is denser. So the ray is going from rarer medium to denser medium. Then what happens? Will it bend towards the normal or away from the normal? Rarer to denser. What happens? It will bend towards the normal. So see, it is bending towards the normal. This should be the direction of incident ray. But it bent. It bent in which direction? Towards the normal. Normal is upwards. Understood? So that's how it is. So you have to be careful. The laws of refraction are valid. Okay, but you have to look at the curve carefully. So drawing the normal is important and then figuring out whether it is rarer to denser or denser to rarer is also important. Good? Okay. I'll go into other examples also. Now we'll go into the case of denser to rarer, because until now we discussed different cases, but all of them were rarer to denser medium. Were from rarer to denser medium. But now let's go into this. Here, let's say normal passes through center. This is a normal. And if a ray is incident along the normal, it is again the case of, what is this case called as? The ray. The incident ray is incident along the normal. It is the case of normal incidence. And in normal incidence, you need not worry about anything, because the ray directly passes through without any deviation. So this is incident ray and this is refracted ray. That's it. Incident ray and refracted ray. Good? Okay. Then, other examples. Now we'll go into this case. This is the incident ray. Now look at this carefully. This is air. This is glass. Air is a rarer medium and glass is a denser medium. So the ray is going from denser medium to rarer medium. Ray is traveling from denser to rarer. That is the case that we are discussing now. We figured it out. Then the other step will be to draw the normal. We have drawn the normal. So if the ray is going from denser to rarer medium, does it bend towards the normal or away from the normal? How does the ray bend? If it is denser to rarer, the ray will bend away from the normal. So this should have been the direction of incident ray, but it bends away from the normal. So this is what it is going to be. That is how refracted ray is going to be. Okay. So case to case you have to be careful. The steps are very simple. The steps are very simple, but we have to be careful about case to case. Okay. And here, if I ask you, which is medium 1, air or glass? Which is medium 1 in this case, air or glass? What is that going to be? Think about it. Which is medium 1, air or glass? The correct answer is glass is medium 1. What is medium 1? Medium 1 is a medium in which there is incident ray. And the incident ray is in glass, so glass is medium 1. Refracted ray is in air, so air is medium 2. Medium 1 and medium 2. Is that clear? Good. And here, which surface are we talking about? The ray is incident on concave or convex surface. The incident ray is incident on concave or convex. Look at this. Complete the sphere. So the ray is incident on what? On the inner surface. What is the inner surface? Concave. Okay. So you have to look at things with respect to what? With respect to the incident ray. From the incident ray you get the medium one. From the incident ray you get which surface it is, concave or convex. Okay. Now another case, this case here. Now you tell me what's happening. I'll take the normal. There is a ray, see the ray, look at this ray. It is going from what? Denser to rarer. But it is incident along the normal. Then what will happen? If it is incident along the normal, what will happen? It will directly pass through, no deviation. So you have incident ray, you have refracted ray. That's it. You need not care about anything else. It is the case of normal incidence. Got it? Okay, good. But if I have any other case, the ray, again see, here it is air, here it is glass. Air is rarer medium, glass is denser medium. So the ray is traveling from denser to rarer. Denser to rarer, and it is not the case of normal incidence because I have drawn the normal here. The ray is not incident along the normal. The question is, it is going from denser to rarer, so how does it bend? Towards or away? If it is going from denser to rarer, it will bend away from the normal. It will bend away from the normal. This is the direction of incident ray. If it bends away from the normal, it will be something like this. This is the normal. It is bending away from the normal. Is that clear? See, so if you stick to the basics, if I stick to the basics, any case I will be able to solve it. And what is medium 1 here? Air or glass? Which is medium 1? Air or glass? Everyone? Which is medium 1? The incident ray is in glass. The incident ray is in glass, so glass will be medium 1 and obviously air will be medium 2, because for us it is going to be very important to identify medium 1 and medium 2. When we go into the formula part, you will understand why is it so important. Sorry, glass is, my mistake, glass is medium 1. This is incident ray. The medium in which there is incident ray is the medium 1. Good? Okay. So now we understood about the cases, about different cases. So please practice them. Okay. All the cases, practice them again. In fact, draw it and practice so that you will have clarity. Good. Now let's say I just have a I just have a curved surface. Now for this curved surface, there will be geometric center, which we will call it as pole P. And if this is the center, then the line passing through center of curvature and pole is the principal axis. Very simple. Okay. But coming back to the question here again. If an object is present here, let's say somewhere here. If an object is present here, so obviously it has some object distance. This is what the object distance, and for object distance we use the symbol U. Same as the case of mirrors, same symbols. Yes or no? Object distance. The question is, if the object is placed here, where will the image be formed? Can we get the image distance? Can we? The answer is yes. And for that we use this formula. Sorry. Just a minute. We use this formula, mu2 by v. It's an interesting formula. Mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r. Now we know what v is. What is v? V is image distance. From where is it calculated? From pole. From pole. What is u? U is object distance. From where is u calculated? Again from pole. And what is r? R is radius of curvature. R is radius of curvature. Okay, all this is fine. But the question is, what is mu2? What is mu2? It is refractive index of medium 2. That is the reason why I was focusing on medium 2 and medium 1. It is more important to identify them. What is mu1? It is refractive index of medium 1. There are 5 terms here. Refractive index of medium 2, refractive index of medium 1, image distance, object distance, and radius of curvature. So using this formula, we can calculate the image distance. Sir, is there a derivation for this? Yes, there is a derivation. We'll do that in the next class. But for now, we'll understand the formula and how to use it. And remember, when we use the formula, sign convention is important. That is, V, U, and R should be substituted or should be used with proper sign. And what is the sign convention? It is same as the case of mirrors. It is same as the case of mirrors. That is, here we have the object. Let's say this is the object. From the object, the rays will be something like this. This is the incident ray. So along the principal axis, the incident ray is towards right. So the direction of incident ray is positive and the opposite direction is negative. And the distances are measured from this point, pole, always. So here, if I look at the object distance from pole to the object, it is towards left. That means U is negative, object distance is negative. And if I look at radius, how do I find the radius? Again, for radius, you go from, every distance is measured from pole. So from pole, I go towards center. In which direction am I going? Left. And what is left here? Left is negative. So radius will also be negative. And we will depend on where is the object. Okay. So let's go into one simple problem, very quick. Every point that we discussed, what is mu1, mu2, r, v, and u are clearly given. That's for your reference. Okay, but we discussed those points. Now I'll go into a simple question here. A very simple question. A small point object is placed at O at a distance of 0.60 meter in air from a convex spherical surface of refractive index 1.5. If the radius of curvature is 25 centimeter, what is the position of the image? See, object distance is given, radius of curvature is given, refractive index of the medium is given. We have to find the image distance. So let us first of all try drawing the diagram. Which surface is given? Convex spherical surface. See, how do you decide convex and concave? It all depends on incident ray. So incident ray is falling on the first surface, and what is the first surface here? Convex. That's how you decide whether it is convex or concave. You look at the incident ray. So here incident ray is falling on surface 1. That is the reason why it is convex. This is the pole. So if this is a surface, the center will be somewhere here. Right. So now if I look at the radius will be from pole to center. Is it positive or negative? For that, look at the direction of incident ray. It is towards right in general. So towards right is positive and towards left is negative. See, this is the reason why it is important to draw this, to understand what is convex, what is concave. If you take the other surface, then you'll get the sign of radius wrong. You have to be careful. Right, so it is towards right. See, this is radius. From pole to center, it is towards right, and right is positive in this case. That means, according to the given information, radius is what? Radius of curvature is 25 and radius is positive. So I'll take it as 25 centimeter, positive 25 centimeter. So we got the radius, yes or no? Yes. Then what is the first medium? See, A small point object is placed at O at a distance of 0.60 meter in air. So this is the first medium and that is in air, and this is glass. The incident ray is in air, so that is medium 1. And what is the refractive index of air, everyone? Refractive index of air will be equal to 1. And obviously if you look at the glass, the other medium will be medium 2. Medium 2. And what is the refractive index given as? 1.5. Mu 2 is refractive index of glass, that is 1.5. We have radius of curvature, mu 1, mu 2, both of them. Then comes, what else do we have? The object is placed at a distance of 0.60 meters. So if you look at the object, and as always object distance is negative, because from pole to object you can see you are going towards left, and left is negative. Object distance is always negative. So u in this case is going to be negative. So minus, what is the object distance? 0.6. So minus 0.6 meter. So I have radius of curvature, I have mu 1, mu 2, and I also have u. I have to find out v. What will we do? The formula. Mu 2 by v minus mu 1 by u is equal to mu 2 minus mu 1 by r. I just have to substitute mu 2 is equal to 1.5. 1.5 is 3 by 2, by the way. 3 by 2 upon v. We don't know v, we have to find out v. mu 1 is 1 and u is minus 0.6. Now what I'll do is, radius is in centimeter, the object distance is in meter. I'll convert that into centimeter. It is going to be minus 60 centimeters. 0.6 meter is what? 60 centimeter, right? So u, I make use of bracket so that we will not go wrong. Minus 60 is equal to, again, mu 2 minus mu 1, mu 2 is 3 by 2, mu 1 is 1, upon radius, what is radius? 25. That's it. If you solve it, you will get the answer. Let us solve it. 3 by 2v, minus into minus plus, 1 by 60 is equal to 3 by 2 minus 1, 1 by 2 by 25. Then again 3 by 2v is equal to 1 by 60 goes to that side. What happens? It becomes negative. 1 by 2 by 25. 2 comes to denominator. 2 into 25. 50. 1 by 50 minus 1 by 60. Then again you have to proceed with the calculation. 3 by 2v. 50 and 60. If I take the LCM, what is that going to be? 5 and 6. 30. Right, so it is 300. So I can just say it is 6 by 300 minus 5 by 300. So 3 by 2v is equal to what? 1 by 300. Is that correct? 6, 300, 5, 300. Yes, that's correct. Then if I want to find v, I'll again do the reciprocal. Because see, v is in the denominator. So if I do the reciprocal, 2v by 3 is equal to 300. And I'll say 2v is equal to 3 into 300. V is equal to 3 into 300 by 2. I think you'll get the answer as 450 centimeter or 4.5 meters. Simple, right? Good. Okay, so please do this problem again. Practice it again. Okay, so that it will be easier for you. So that's it, everyone. That's it for today's class. We'll again continue from the next class. Okay, thank you. Thanks a lot.